changing the vision appropriately. And my fundamental thesis for what I call the lean startup is that if we can shrink the time between those iterations, we can increase the odds of startup success. Okay? So before we get to that, let's talk about you for a second. I'm curious, just a quick show of hands, how many people in this audience are thinking about creating a startup someday in the future? Thinking about a startup, anybody? Okay, good. How many people, any people in a startup right now? In a startup right now that could go a little bit faster? Okay. And third thing is, how many people are in a larger organization, enterprise, government, nonprofit, that is still trying to create startup-like conditions of innovation? Anybody? Okay, all right, that's a really different ratio than last time, so I will try to adjust accordingly. And my promise is I promise to have something relevant to say, I hope, for all three of those groups, because I think all of them have something in common. They're all in a startup. So we hear the word startup, we think, oh, two guys in a garage, right? That's a startup. And it's true, two guys in a garage generally is a startup. But I don't think that's a good definition for startup. I think we need to think a little bit broader. What startups have in common is the context in which they operate. That is, they're trying to create a new product or service, and they're trying to do it under conditions of extreme uncertainty. So anytime you find yourself in a situation where you don't even know what you don't know, that's a startup. And I thought I'd tell you some stories of people who are in that situation. The people are me and my friends, in two particular startups that I've been in, where we confronted the unknown in somewhat different ways and got somewhat different outcomes. First one I'll just call startup number one. This is like generic brand A. This is a company I flew out and moved to Silicon Valley in order to join. I was so excited by the plan this company had. This is considered, in Silicon Valley, the world hub of entrepreneurship, this is considered a very good plan. Let's create a company with a compelling long-term vision that wants to really make the world a better place, not just some incremental improvement to some feature on some whatever. So we had, let's raise plenty of capital. Let's raise it from really top-tier so-called smart money investors. We had fundraising. We raised money from some of the best investors in Silicon Valley. Let's hire the best and the brightest, the absolute smartest people we can find, true experts in their field, and let's get them really psyched about this vision so that they will invest all of their time and energy, every waking hour, into building this company. And let's get a seasoned and experienced management team, people who have really been through it before and know what to do. Let's make sure that we build a mainstream product. Screw these early adopters, whatever. We want to go straight to the mainstream and build a product of superior quality that's simply better designed than everything else on the market. That's extremely easy to use, it's intuitive for a very broad market. And let's build a compelling technology platform. Because let's actually do some heavy lifting and accomplish something in this world that's not easy to replicate. And the last thing, most important, let's build buzz by doing this whole project in stealth. So we'll take all these smart people and we'll just take them off the radar. What are they working on? Can't be disclosed. Right? So bloggers who are interested, no comment. Journalists who are like, ooh, gotta get the scoop, sorry, can't talk, it's a secret.
Not too far.
The purpose is not just, because we thought that was cool in little James Bondy. The purpose served a very specific strategy. When it's time to launch this product, we want to have a launch that mainstream press is going to cover, and that those mainstream customers we're building this high-quality technology platform for, they're going to hear about it, because we are going to really blow this thing up. People are really going to hear about it. And so that was the plan. And what happened, we did something I call achieving failure. Because this company failed utterly, and it set about $40 million on fire. So this was an extremely painful and humiliating failure. This is not the kind you want to repeat. But the reason I call it achieving failure, the problem is not that we failed to execute the plan. And I got to drive this point home. If you don't understand this, the rest of the talk's not just going to be complete gibberish. We executed that plan exactly like it said. We hired the people, the absolute best and the brightest. We built that technology platform. It was a high-quality product. We had the launch like you would not believe. Wall Street Journal, New York Times, all the right tech columnists and bloggers saying that this was the future of the internet. It was a disruptive this, and everyone wanted, it was really very successful. So we did the plan, and yet we crashed and burned. And the reason, I believe, is because in addition to the things I mentioned that are in the plan were some other things. What I call shadow beliefs that were commonly shared by everybody in the company, but were never written down anywhere in the business plan. And I want to talk about 3 such beliefs with you today. The first one is we know what customers want. which is kind of obvious when you think about we're going to start a startup, we're going to invest years of our lives. Shouldn't we first make sure we know what customers want before we do that? In fact, I mean, isn't that the whole point of a startup? Right? That you have an idea, a vision of what customers might want, and you decide, hey, let's build it and see what happens. So we had such a strong belief in what customers wanted that we were actually immune to data to the contrary. Because we had, remember we were in stealth? The great thing about stealth is it's a customer-free zone. But we were 5 years with no external data. So it's not that this company wasn't metrics driven. We used a lot of metrics to make sure we delivered on time and we hit schedules and everything was going well. And it's not even that we weren't customer centric. We had customers in for focus tests and usability studies, and to make sure that the way we were building this product made sense. But at no point were we really dedicated to answering the question, when we're done with this product and we're ready to sell it, are there going to be any customers for it at that time? Turns out that there basically weren't. Second shadow belief, that we can accurately predict the future. And this surely doesn't say in the business plan. I mean, you'd be considered certifiable if you're like, hey, we know what's going to happen in the future. But in the business plan, there were a lot of charts and graphs, a lot of spreadsheets that said, listen, when we ship this product, here are some very specific things that are going to happen. And the company was built from the ground up to be ready to handle those things when they did happen. For example, this company was going to have 1 million simultaneous users shortly after the launch. And so our technology platform had to be able to scale to 1 million simultaneous users. This is a virtual worlds company. So this is a heavyweight back-end system. It has to have the load partitioned appropriately. Those of you who are architects in the room know that in order to do that, you need to have a pretty accurate model of what customer behavior is going to be so that you can partition the load accurately. What if your model proves even slightly inaccurate? Not so good. More importantly, we had to have staffed up the employees necessary to serve those 1 million customers. So we had to have customer service, operations, QA, sales and support ready to go. This company, I think, was 200 employees before customers saw the product for the first time. That's where the $40 million went. Third one, this is my personal favorite. This is what makes achieving a failure possible. The idea is that advancing the plan is progress. Right? So when we would when we build the specification for a feature, we would celebrate. When we shipped the feature to QA, we would celebrate. When QA certified the feature as ready to go, we would celebrate. We were making progress. And this is true of almost every startup I have ever worked with. The people are busy. You never see a startup that's idle. The founders keep everybody busy. That's their primary job. And I think the deep, hidden anxiety, and I'm willing to say this publicly, and I think other founders that they're being honest with too, the deep anxiety you have as a founder when you go to sleep at night is you're like, okay, another day went by, I spent my investors' money, but I kept everybody busy. Did we make progress? Did we really? How do you know? And I think the problem with advancing the plan as your unit of progress is that you get constant positive reinforcement. Every day, you are getting this kind of checkbox that says, good job, you made progress. But I think, unfortunately, it's a phony unit of progress. And it's giving you positive reinforcement for bad behaviors. Sometimes, I don't know if there's anybody in the audience who feels this way, but sometimes when I give this talk, I kind of get the response something like this. Yeah, okay, it's kind of obvious. Okay, look, everybody knows you don't know what customers want. Everyone has a certain amount of humility. Like, seriously, what's new here? But I want to look at this good plan one more time. And just, all I do is ask you to think for yourself. Ask yourself, if I negate each of those 3 shadow beliefs, would I really adopt a plan like this? Is there any bullet points on here that strike you as a little bit funny? If you really said, we do not know what customers want, we cannot predict the future, and advancing the plan is not progress. And I think as an industry, we talk a really good game about humility, data-oriented decision-making, being customer-centric, our power to innovate, and all that stuff. But I think you judge a person in an industry and companies not by what they say they do, but by they actually do. And I think our actual behavior does not live up to the ideals we like to think of ourselves as having. And so, I got to try again. And this company I can name, it's called InView. And since it's pretty much charts, arrows, and diagrams from here on out, I thought I'd bring some pretty pictures. So enjoy them while they last. InView is a 3D avatar social networking and instant messaging product. We founded it in 2004. And I'll tell you a little bit about what happened since then. The thing I think is relevant for today, most relevant, is that because we had such a humiliating failure, startup number 1, the co-founders of this company and I, we kind of had the psychological freedom to try something different. We were like, listen, for God's sake, let's at least make new mistakes this time. It was just, if we're gonna be humiliated in public, let's at least have it be for something we actually believe in. And so we had the chance to kind of question all of our assumptions from the ground up and say, we're just gonna try to do something different. And so we built a new plan. This new plan was consisted primarily of processes that were considered a little bit crazy. So people were giving us feedback on this plan. We did not get very positive feedback. This was not considered best practice at the time, nor I think is it now. But we wanted to try it anyway. So here's some of the bad ideas we put in this plan. First is we shipped this product in its entirety in 6 months. Now, see, I can see already there's some engineers in the room who are kind of smiling as they do the math. Wait a minute, if it had 3D avatars and 3D rendering and social networking features and instant messaging, e-commerce and user-generated content, forums, blogs, and they're like, and you did all that scope in 6 months, what trade-offs had to be made in order to make that happen? Which is a very kind euphemism for saying this product sucked. Okay, I am willing to admit this is one of the worst products ever shipped to customers in the history of software. This product was buggy, it had a horrible UI, it would crash, practically crash your computer if you were dumb enough to run it. But we decided anyway, we would ship this product in full open public beta. We were not hiding behind private focus groups and special codes and access this. We were like, listen, we are risking the full peril of our brand by putting this product out under our own names, never mind what it meant for our careers. I mean, as the primary VP of engineering of this company, I shipped this low quality software. That was a little bit scary, so a little empathy might be in order. And we were risking the brand, right? Our most precious attribute. Customers are going to try this thing and think that our brand stands for low quality. But we needn't have feared if no customers tried it, right? Because you should be so lucky that anyone tries your product and conclude that it's no good. It's actually incredibly difficult to get anybody to try any product. And if you don't know who your customer is and what they want, it's actually a lot harder than it sounds. So we did that. We also charged people money for that product. So now we're talking about a really bad idea, right? Beyond the obvious conclusion that you shouldn't charge people money for a bad product, that's crazy. Also remember, this is a communications product, an instant messaging product. And I see some people are kind of looking at themselves like, wait a minute. Everybody knows that communication product is associated with Metcalfe's law that says the value of a network is proportional to the square of the number of participants, which is a fancy way of saying you need critical mass for an instant messaging product before it's worth anything. And some simple math will say if you charge people money, less people are going to use it, and that means you're not going to get to your critical mass. And we have plenty of investors who told us that, and we're just like, you are nuts. That's crazy, right? You're going to ruin the very thing you need to make this communication product work. But we thought it was more important to do what we thought of as testing the riskiest part of our product hypothesis as early as possible. Since we actually had failed before based on hype and PR, this time we actually cared whether we were right or not. And we thought the riskiest part of our product hypothesis was this. We're going to get real people to pay real money for virtual clothes for their virtual avatar. Which I guess, when I used to tell that story in business school and stuff, I used to get a bigger laugh than I get now, because now it's considered a little bit fashionable that, oh yeah, for everyone knows virtual goods is a great business model. But listen, in 2004, we got plenty of laughs when we told that to investors. And we kind of had that anxiety ourselves. At the end of the day, are people really going to pay money for this? And we thought, all right, let's find out. And so from day one, we were charging people to get those virtual clothes. And that meant since day one, we have been in continual and constant contact with true early adopters. The kinds of people that would buy and pay for a crappy product because they see the vision of where we were headed as well or even better than we do. And that's a notion that can be hard for founders to accept. Visionary customers, what are you talking about? I'm the visionary. I'm the one who tells customers what to do. They don't tell me. But I think that's a mistaken idea. I think visionary customers get where you're going better than you do. And so talking to them in the early days is essential. Plus, most startups, nobody else will talk to you anyway. So you should be so lucky that you get a mainstream customer on the phone. Good luck. We did something else that's considered a bad idea. We ship software multiple times a day. This number has been increasing over time. Recently, they're pretty private with their stats, but it's about 50 times a day on average these days. That means on average. So some days we do more, some days we do fewer, but that's about the number. Which means from the time that a new feature or even any piece of code, refactoring anything, is written, it's about 20 minutes for it to be out in production. And the engineers in the room now are definitely looking at me like, oh boy, this guy is smoking something, right? Because we all know, think of all the things that could go wrong if you do that. Random engineer, yeah. Oh, here, maybe we'll get one.
What about the bandwidth of shipping it? Or is it just to the server rather than all the clients?
We're deploying to production, which we think of as our server environment. but it immediately changes the download code of people who are making a download. If the change was to the downloadable piece,
Okay.
as well as if you practice some of the methodologies we're going to talk about, you inevitably move logic from the client to the server because you can iterate faster. But I promise we'll get to that in a lot more detail later in the talk. So anyway, bad idea, right? You can think for yourself the things that could go wrong here. Random engineer takes the whole site down because they're like, hey, this will be fun. Infinite loop. So we'll talk about it, right? Cute prank. And we've had that happen. But we thought that the risk of those kind of bad things happening was much lower than the risk of having to kind of sit around and wait before we could find out whether the features we were adding were any good. Plus, it turns out with good process, something called continuous deployment, which I promise we'll talk about towards the end of the talk, you can mitigate all the problems now. So hold that thought in your mind, and I promise to return to it when the time comes. No PR, no launch, so we would not talk to the press. We had journalists call us up and say, could you comment on this? And we said, no. We're too busy serving our customers. We don't have time to serve you too. And although our investors really didn't like that, because they didn't get to read their names in the paper, and it was hard to have nothing to show mom to say, look, I'm really doing a good job, we think the results spoke for themselves. Imbu doesn't speak publicly very often about its metrics, so all I can say is what they've said publicly, which is 2007 revenues of about $10 million. We've created about 40 million avatars for people over the years, and then the company's thriving and doing quite well. So we did everything wrong, but we got a much better result than when we did everything right. And that kind of paradox is what led me to spend the last 8 or 9 months thinking and writing and talking to people about what does this mean for how we think about startups in general. So I've been writing that blog, Startup Lessons Learned. Thank you to those of you who had a chance to read. I've been working as a consultant with a number of startups, as well as with some VCs who invest in startups for a living. And I had a chance to meet a lot of audiences like this. And I have developed this theory, I call it the lean startup, which is just a different way of building companies from the ground up so that they go faster. Because ultimately, I think it's the speed of iteration that determines the success of companies. And I think the speed of iteration that's possible in a startup today is dramatically higher than it ever has been in the history of mankind because of 3 very simple trends. The first, which I assume is well understood here, the commodity technology stack. Second, something called customer development, which is a methodology parallel to product development for finding out what customers want before you spend $40 million building it. And third, of course, agile software development, but not the traditional agile that's used in big companies, a slightly different variation that is specific to the startup condition, which is what most of what we're going to talk about today. But since I had three things, I feel like I got to go through the three things one at a time. Here's the first. I want to talk about the commodity technology stack just to introduce this concept of product development leverage. These days, leverage is kind of a dirty word because of its financial connotations, but in product development, leverage is a really good thing. What it means is, for every ounce of energy you invest in your product, hundreds, thousands, maybe even millions of other people invest along with you. Which means you don't have to get people's permission to make that happen. You don't have to go sign a really complicated contract with some vendor. You don't have to get a government license. All of these open APIs, free and open source software and hardware, everything we call Web 2.0, but also leverage distribution like Google AdWords. All of that means you can very easily get product prototypes built. And that's true not just for software products. Of course, there aren't any non-software products left in the industrialized world anymore. But even if there were, even if you just wanted to build a totally dumb product, you still could distribute it over the internet. And therefore, you could build prototype marketing, landing pages, e-commerce functionality to find out, does anybody actually want this thing that I'm building? You could do that for hundreds of dollars instead of millions. And you could do it in days instead of years, which I think is a really radical development. For customer development, I wish there was more time to talk about this, but I can't, so I'll just plug a book. This book is on the 4 Steps to the Epiphany. It's been written by someone named Steve Blank. If you're in a startup today and you're not reading this book, shame on you. So please go out and buy it. And if you use this bit.ly link, I get a commission, so please do that instead of just Googling it on Amazon. No, I'm just kidding. Buy this book by whatever means necessary, because it's a really powerful idea. And the idea is simply, if we spend so much energy having a methodology for how we manage product development, why don't we have a corresponding methodology for how we manage what we used to call marketing and business, since those things are equally important. And for the engineers in the room, and who are kind of used to being like, yeah, business, I delegate that to other people, doesn't work that way. I didn't tell you that startup story, but that leads to total disaster too. And this is a book that can help guide you out of that mistake. So for the agile development piece, I have to back up a little bit. And I want to talk about that tale of two startups again, and I want to do it schematically. And what I mean by that is that I think that my experience is by no means unique, and is actually mirrored by what lots of people have been going through over these past few years. And in some audiences, I have to really disclaim and apologize that all my examples come from the world of software startups, so I always, at this point, have to pause and say, but there ain't no non-software products anymore, as I already mentioned. And secondly, there are no longer any safe industries. So it used to be that some businesses were considered safe, secure, just incrementally generate cash, year over year. But I think that the situations of uncertainty and unknowns that startups have really been bred to confront are confronting more and more companies every year. At the very least, one day you will face competition from a startup. And if they're a lean startup, God help you. So, since we're talking about product methodology, it's traditional to beat up on the waterfall methodology first. So, okay, here it is. Requirements, design, implementation, verification, maintenance. And this is a fun one to beat up on, because this is what makes achieving a failure possible, because the unit of progress fundamentally is advancing to the next stage of the plan. But actually, waterfall is a perfectly reasonable thing to do. It's a methodology very well adapted to certain situations, and I believe that situation is characterized as follows. Both the problem and the solution are relatively well understood. So you can, if you follow these steps rigorously, you can predict what the outcome will be. It just so happens that no startups are in that situation ever. And more importantly, very few software projects can be counted in this situation. I mean, the stats on waterfall development applied to software are really alarming. Again, pick your study, but something like 6 out of 10 projects fail outright. Outright, that means the lucky ones are the ones that come in way late and way over budget. Which I just think, when you think about that, that's a really radical change from the kinds of products we used to build in the past at a much lower mortality rate. So, I don't have to, this is an audience where I don't really need to lecture about the power of Agile, I hope. Agile software development is extremely well adapted to a situation where the problem is relatively well known, but the solution is unknown. And when you do that, when you start to build your product iteratively using a methodology I've diagrammed here from extreme programming, but there's a lot of really good choices that I strongly recommend. And if you're not doing at least this in any kind of software situation, you're really in trouble. If you are, think about what it means for your unit of progress. The Agile Manifesto, famously says the unit of progress for a software project is a line of working code. So if you accomplish something, in quotes now, like a specification document or documentation, or God forbid you have a meeting, that ain't progress, unless it directly translates into somebody being able to write a line of working code. And working code, not write code with bugs in it, that just means you're going to have to go back and fix them later. The canonical Agile project is something like a big company needs a payroll system. And that's, like the old payroll system runs on mainframes, and now we're going to build a new system that runs on more modern hardware. And that's a respectively difficult problem. And I don't mean to minimize how hard it is to get a large IT department to do something of that complexity. But I do want to point out that asking yourself, what problem are we trying to solve, is actually kind of stupid. It's really clear. The new payroll system needs to do exactly what the old payroll system already does, because every company already makes payroll or it wouldn't exist. And so we can use some practices like from extreme programming, the idea of having an authoritative in-house customer who sits with the engineers and answers their questions about what the product is supposed to do. Or in other situations, we have more of a product owner, a product manager who's done the homework to know what the customers are going to want in the future. And you have them sit there, so instead of like, oh, I have a request and I need to get my manager to ask his manager's manager to get an answer. Instead, I just turn to the person on my left and say, what the hell is payroll anyway? Can you explain to me why we're doing this? And you can get an answer. The problem for startups is what happens if the problem you're trying to solve is also unknown. That is, if you don't even know who the customer is, who can you sit with the engineers to answer their questions? And if you can't model what customers are going to want in the future, how is the product owner supposed to make intelligent prioritization decisions? So I think we have to have a change in the way we conceive a startup company. One implication is that we need a company-wide feedback loop, where instead of having departments, which I think are anathema to the startup condition, we need to conceive of ourselves as having a problem team made up of the kinds of people who used to live in what we used to call marketing, business development, and sales. And we need to have something called a solution team, where the kinds of people who used to live in a department we called engineering, QA, product management, or design live. And each of those teams is working iteratively on their part of the solution, but they're also sharing feedback, insights, analysis, and most importantly, data with each other in a company-wide feedback loop. The no departments thing, by the way, I think is the most radical of the suggestions that I will make today. It's the one that will have the biggest immediate impact on any startup that attempts it, and it is the one that I'm very confident nobody here will actually try. Because our conception of what a company is so deeply embedded, we can't get away from the syllogism that all companies have departments, startups are companies, therefore startups have departments. And so if I can at least shake your faith in that syllogism a little bit today, I'll consider this talk to have been a success. The one other thing I want to talk about while we're looking at this diagram is that we've had yet another change in the unit of progress. And let me illustrate with a story. When we started life at InView, I told you it was that instant messaging product, and we talked about Metcalfe's law and then the power of network effects. Here's the strategy we came up with at the whiteboard. It went as follows. Everybody knows that instant messaging is a network effects business. Therefore, the incumbents have tremendous advantage. Why? Because to switch instant messaging networks, you have to take your whole buddy list with you. Hence, you and your friends have to all switch en masse, which is really difficult to orchestrate. Therefore, there's high switching costs to go away from an instant messaging network, which means that instant messaging enjoys high barriers to entry. QED, you cannot bring a new instant messaging network to market. It's practically impossible. So we had a strategic brilliance. The idea was, all right, we won't build a new instant messaging network. We'll create an instant messaging add-on that will interoperate with every IM client under the sun and allow you with one click of a button to transform your old 2D instant messaging into 3D instant messaging. Sounds good, right? Very low switching costs, no need to learn a new program, no need to have a new buddy list. You and your friends can just, whenever you want, switch from 2D to 3D and back again. With me so far? When I do this in MBA classes, by the way, I get really vigorous nodding, like, boy, those guys are smart. The only problem with that strategy is so brilliant, and the only problem is that each one of its underlying assumptions that I just told you with is wrong. There are not network effects in this business, there are not strong switching costs, and there are almost no barriers to entry to bring a new instant messaging network to market. Just empirically incorrect. For example, most teenagers who turn out to be in the target customer for this kind of product run 7 or 8 instant messaging clients simultaneously. And the idea of like adding another one, they're like, what's the big deal? I mean, we would do these usability tests with a teenager, and we'd be like, they're like, well, where's my new buddy list? We'd be like, oh no, you don't want a new buddy list because it's interoperating with the network effects, switching costs. And they'd be just like, what the hell are you talking about? You're crazy. Plus, their favorite thing about downloading a new piece of software is they get to tell their friends that I found the cool thing before you did. Oops, right? It gets even worse. They've never heard of an instant messaging add-on, and they won't download such a thing because they don't know what it is. We'd be like, try this new instant messaging add-on. They're like, what's that? Well, yeah, it's this thing that interoperates with it. And they're just like, is it an instant messaging network or not? And we'd be like, oh, it is. Check it out. Whatever it takes to download it, right? And then we had a further problem. Imagine this usability test. Here I am with a teenager, and like, okay, now customize your avatar register. We're like, okay, that's pretty cool. And we're like, all right, now for the viral growth piece of our strategic genius, every time you want to use this product, you have to use it with a friend. Therefore, it will inherently be viral, right? Does that sound good? Only problem. Okay, check it out. Now you have your avatar. They'd be like, okay, interesting. How do I try it? Oh, invite one of your friends. No way. Why not? I don't know if this thing is cool yet. I'm not going to risk inviting one of my friends. We'd be like, but it'll be so cool once you do invite your friends. And they're like, not convinced. Let me try it by myself first. We were from the video game industry, so we're like, oh, we know what that means. They're asking for single player mode. We can build that. So we built single player mode. You bought the product, it would let you play with your avatar and dress up and show you all the cool things you could do. And we'd be like, blah, blah, blah. Okay, now invite one of your friends. They'd be like, sucks. Like, we told you it was going to suck. It's a communication product. You need to invite your friends. They're like, yeah, not convinced. And we were just stuck on that problem for the longest time until we realized what they were really asking for was the ability to use the product with somebody else, a stranger, not one of their friends. So we built this feature called Chat Now, which is still a core part of InView. It allows you to randomly match with somebody else from around the world. The only two things you two have in common is that you both push the same button at the same time. That's it. True stranger. And so people would do that, and they'd be like, oh, this is kind of fun, and they'd meet that person. They'd be like, cool, I want to add that person to my buddy list. And we'd say, oh, well, you don't want to have a separate buddy list because of the network effects and switching costs and blah, blah, blah. So just give them your AIM screen name. They're like, give my AIM screen name to a stranger? Like, you're crazy, man. No way. They're like, what's the big deal? Just give me my own buddy list. Right? And we just went on and on with just like the incredible amount of resistance we had to this idea was staggering. I tell you that story partially just so you can see that we were pretty dim, but also I want you to now go back to being empathizing with me. Remember, I'm the primary technical co-founder. Who do you think wrote the tens of thousands of lines of code required to do IAM interoperability? You're looking at it. And that code, turns out, had to all be ripped out and thrown away. Like, not because it wasn't well documented, not because it wasn't well structured, not because I didn't create unit tests, not because we didn't have continuous integration, for no other reason than customers didn't want what it did. It was built to specification and it worked great. Except that the biggest form of waste in any startup is building something that nobody wants. And that's not a technical problem. And no amount of agile software development is going to help you with that problem. Because the unit of progress is not a line of working code. It's what I call validated learning about customers. In our case, it was $, $, $. That is, until we could prove that we could get customers to pay us their hard-earned money for the thing we were offering, we didn't consider ourselves to have made any progress whatsoever. And the other thing that's kind of interesting is that locates progress in a startup firmly in the heads of the people who work there, and not in any other artifact, including the product itself. So let's simplify a little bit. I've written the simplest possible diagram to describe the functioning of a software company. What is a software company? It is a very large organism that is fundamentally a catalyst for transforming ideas into code. It has no other function. Luckily, sometimes when we ship that code to some customers, we can measure what happens as a result. And if we're really advanced, we can use that data to learn something about our next set of ideas. And when I talked at the top about those major iterations for startups, this is what I mean. This is the fundamental feedback loop. It's the total time through this loop that matters for determining the success of any startup situation. And the problem with almost all of the so-called best practices that people port into startups is that they optimize one leg of this feedback loop, which, as those of you who understand systems analysis know, necessarily sub-optimizes the total loop. So for example, I'll just pick one, my favorite, the data warehousing fallacy. If measuring a few things is good, measuring more things is better. Which, that's optimizing for data collection. Let's have 10,000 graphs to tell you anything you could ever want to know about what's happening with our product. Only problem, no human being is capable of learning from 10,000 graphs. And so although we've got better at measuring, we've gotten worse at learning. And all of the other best practices have that same character, and they're established because they actually work. Like, they really do optimize the job of somebody in one department. That's why departments are so hazardous to the health of startups, because they tend to optimize for their own part of the product rather than for the company's product for the company as a whole. So that's it. This is the heuristic you need to evaluate any process to say, hey, is this really a net win for my startup company? And my suggestion is that any process that fails that test is a source of waste and should be eliminated. And to prove that I'm serious about it, I want to talk to you about 3 specific practices that I recommend for startups that I view as kind of the heart of the lean startup. These specific practices were evolved in my experience with the software startups that I work with, and so your mileage may vary. In fact, your mileage will vary. Please do not try this at home. Don't just directly port these practices into your company. That will almost certainly lead to disaster. But try to think about the underlying principles that make these processes work, and think about how would I apply those principles to a startup that I'm either in or thinking about creating. Before I get into the specifics, are there questions about the kind of theory that we've talked about so far? Yeah?
When you talk about you said no departments, does that mean no specialization of tasks?
It's okay to have specialization of tasks, but the fundamental unit that we want to use to manage our company is the cross-functional team. And we want to judge every member of the team by the success of the team as a whole. So, although, in NMU we had engineering managers, and we had, design managers, and we had marketing managers who were there to assist people who were functionally specialized in doing their job better, we would not promote someone because they got better at writing code. That's actually really a bad idea, because then people will really focus on writing code. And if you're like, listen, I need you to QA this thing real quick, they'll be like, I don't get a raise because I got good at QA. Okay, I get a raise because I got better at writing code. Instead, we would judge people as a success and promote them and reward them based on the tendency of the projects that they worked on to be more successful. Successful with respect to what? With respect to delighting customers and nothing else. That is your question? Any other questions theory-wise? Here we go. Let's talk about continuous deployment. This is something that really impacts the speed at which we can build products, but its primary purpose is not to affect that leg. It's designed to affect the total time for the loop. Here's how it works. To do continuous deployment, there's 2 things you have to do right off the bat. First thing is you need to be able to deploy new software quickly. And when I say quickly to you, like I said, I mean 20 minutes from the time you write the code to the time customers are using it. I'm not kidding around. When that time gets to 25 minutes, we start to refactor the process to get the time down. And most of that time is not actually spent pushing code out to machines. Doing the distributed copy isn't the hard part. The hard part is in telling the difference between a good change and a bad change. Almost all of that 20 minutes is taken up in certification, automatic certification, that a change is ultimately going to be good for the business. And if it's not, we're going to revert it. In fact, the system is going to revert the change automatically, using something that I'll talk about in a moment called the cluster immune system. It just rejects something that's a bad idea. To make that work, you got to be able to work in small batches. And again, let me make that concrete. I'm talking about one guy working for 3 days on software. We would consider to be a very large batch. And if it started to be a week or 2 weeks, or God forbid you put 3 guys on a branch for 2 weeks to go work on a project, we would consider that an unconscionably large batch. Like extremely likely to go stale, and extremely likely to have integration problems when you pull it back into the main trunk. So whatever you think about how crazy continuous deployment may be, I want to mention one fact, which is that we never, ever have integration conflicts. It's simply impossible. There's no integration risk in the code that we write, because we have almost no work-in-process inventory. And by integration risk, I don't just mean mechanical source code conflicts. I'm talking about the integration risk that happens when, between the time that I wrote my software and the time it got deployed, some operations guy changed the version of Linux that it runs on in the server, or makes some other configuration change somewhere in production. As soon as somebody does that, they've created a ticking time bomb waiting to conflict with my change. It's going to hit some unknown time in the future. You have a configuration management problem, you're going to find out in 20 minutes from the time you introduce it. To do that, you have to be able to break large projects down into small batches. So we actually build all of our features, no matter how large, effectively in production, in situ. That doesn't mean that we have people logged into the production machines. It just means we break it down into all of the tiny little tasks necessary to get it to work in production. And then when it's finally assembled, then we'll start to show it to the right number of customers. So one way to think about that is, we basically say, we are saying release is a marketing term. Like, from the point of view of the customer, when a feature got released has absolutely nothing to do whatsoever with when it was technically finished. We allow marketing to control all of that, all of the messaging, all of the decisions about how many percent, what percent of customers should see a given feature. We just put it in production and get it working. And then we can incrementally decide who's going to see it. But most of the work of a feature is not the feature itself, but it's all the integration with all the other features, all the underlying APIs that have to be refactored, and all those thousands of little changes that supposedly don't make a difference to the customer. It's just some underlying API, we're adding a default parameter, they'll never notice. How many times is that promise actually kept? That is, what percentage of the time do these so-called idempotent changes actually have no side effects? My experience, it's extremely low. And so what we want to do is make them all one at a time, put them in production, and just make sure that they don't introduce any kind of harm to the business. Here's what it looks like. This is the cluster immune system as we practice it in InView. Actually, this information is a couple years out of date. The system is actually way more complicated now, but I really want to emphasize, my goal is not to get you to go home and build this thing from scratch tomorrow and stop shipping to customers. Instead, you want to follow a process we call 5 Whys, which I'll talk about at the end, for incrementally building up this infrastructure bit by bit for yourself. But anyway, since I want to be specific about how it works, let me show you exactly what it means at InView. The first thing is, we run all of our unit tests locally, which means every engineer, and every non-engineer for that matter, has their own private sandbox where they have a full replica of the entire production environment, where they can run the entire site. Anything they can do in production, we try to make it possible to do in your local sandbox, and you can write tests against it. We have to write tests in 10 or 15 different programming languages because everything is tested. JavaScript, Flash, PHP, Perl, Java, C++, the works. Plus, of course, the end-to-end functional tests that have to be written in browser frameworks like Selenium and all kinds of other test automation software. One side benefit of everybody gets a sandbox is not only engineers are allowed to check into production. If some marketing person is like, you know what, this landing page is ugly, and I'm willing to teach myself HTML in order to make some changes to improve it, I'm fine with that. Let them check it in. Because I'm very confident that they introduce a problem, we're going to find out. Next thing we do is continuous integration. So this, I hope, is well known in this room. People here practice continuous integration? Yes? Okay. Then I won't say too much about it, except we have this metaphor that pushing code into production is like a production line. We borrow that from the Toyota production system as a metaphor. And the idea is anytime something goes wrong, including a test failing in continuous integration, we're going to stop the line, which means nobody can deploy, nobody can check in. So anyone ever had the problem where you have a continuous integration server, but nobody cares if the tests are read? Anybody want to admit to that problem? Yeah, that's been the bane of my career, personally. This prevents that problem and the whole class of problems that represents. Because if a test is read, you simply can't check in, so you can't get any work done. It's impossible. And since we don't allow code to pile up into a big batch, you can't keep working on it either. Yeah.
How you submit the correction if you get submit?
That's how I know that there's always at least one engineer in the audience, because then they ask, well, if you can't check in, how do you fix the problem? And the actual answer is we had a structured comment you could put in the commit itself to say that I am fixing BuildBot. And so if you were lying, people would know, because the email got sent out to everybody. But people who simply can't deal with that, you can also make a rule that you can check in the change from the BuildBot machine itself. You just can't check anything else. All of these procedures require human cooperation and are easy to circumvent. Because if you have a malicious actor in your system, that is somebody who doesn't believe in the process and thinks they can just go off on a cowboy and do their own thing, you've got way bigger problems, and all this is beyond your scope. First, learn how to be disciplined with regard to your development practice. But I'm assuming, given that we have Agile practitioners in the room, people here understand that process does not equal bureaucracy. Process equals discipline. That's what we're talking about. I want to talk a little bit about this automatic feedback. This system of having kind of the commit checks be blocked on certain circumstances acts as a speed regulator for when the team is going too fast. And some people, when I say that, are a little bit confused. They're like, wait, didn't you say that speed is the ultimate weapon and those who go faster win? And that's true, but I want us to go as fast as we can reliably produce a quality outcome and no faster. Because that extra speed you get when you start to disregard your own process and introduce bugs and regress old bugs, that's a false optimization. That's actually, seems like you're going fast, but actually you're slowing yourself down. So you have the old engineer's adage that you can have time, quality, money, pick two. Simply not true, because you cannot trade quality for time. Because the kind of technical defects that you introduce have the effect of slowing you down. They introduce all kinds of intermittency into your system that makes it hard to debug, causes you to waste a lot of time figuring out what the hell does this thing do anyway. Other thing that's important is what I call incremental deploy. This system, when it's time to put code into production, will kind of deploy it machine by machine, and it will monitor the health of each machine as well as the health of the business as a whole. And if it detects something is wrong, it will automatically roll it back. So if I remember that example, I said, let's check in an infinite loop. That'll be a fun prank. Let's say we actually did that. Go back to my desk, check it in, say, hey, let's deploy that to production. Sometime 20 minutes later, there'd be an email. Dear Eric, thank you so much for attempting to check that in. That's a terrible idea. It's been reverted, and we've let everybody know, and nobody can check in now until someone gets to the bottom of what went wrong. So it's just impossible to check in kind of really dumb mechanical change like that would destroy the performance of the system. But I also want to emphasize that that's equally true of business metric disasters. Like my personal favorite, we talked about this in the previous session. Okay, you have an e-commerce website, and there's like a checkout button. It's basically like, okay, now the company makes money and people push this button. So if you remove that button, it's easy to say, okay, well, an integration test will catch that, right? If we get unit tests that, click the button, make sure it works, right? But what about if I'm a little bit more malicious and I say, let's make the button white on a white background. So it's still there, it's just no human being can see it anymore. That's a change that will turn the business from profitable to making $0 per hour very, very quickly. And if we made that change at my desk and checked it in within 20 minutes, it would be automatically reverted. Because the incremental deploy would notice that revenue per unit time has gone down drastically and say, hey, something is wrong, we need to get to the bottom of it. Danger, Will Robinson. And of course, there's a whole set of problems, yeah.
So how often does that trigger in real life?
I would say we get a alert of some kind from the immune system, like, on average once a day. How many of those are really a serious issue? Probably on average once a week. And serious meaning, somebody made a careless mistake that would have had serious consequences if the system hadn't caught it. Which, interestingly, is actually relatively similar to the rates, if you kind of think of them proportionally to like a Toyota production line. They have the famous andon cord, where people can pull the cord and shut down the line if they see a quality problem. There's actually, that cord is pulled quite often every day in most manufacturing contexts. It's just that they have a more advanced system, as now we do at InView, where just noticing a problem doesn't necessarily shut down the line. There's a series of other preventative things that can go in. But if you have a really serious problem, we will stop everybody in the company from working until we get it resolved.
If it's very rare, then you're not going to get good at it.
Right. Exactly right. So this system tends to drive your rate of problems down to the optimal level. Yeah.
How often do nasty problems get in there that don't get detected by the immune
Thank you for knocking me right back on track. Thank you. That's this next section, what we call alerting and predictive monitoring. The idea is there are a number of problems, and this happens more infrequently, I would say maybe on average once a month, where you have a problem that really slips through the cracks but causes a severe problem that someone needs to get paged in the middle of the night. And a human being needs to be like, what the hell just happened? This tends to be more often external events, like some system we depend on goes down or there's a power outage. But actually, we catch a lot of those problems in continuous integration, since we actually integrate. We have unit tests that integrate with all of our external vendors to make sure that PayPal is still taking payments. They're still taking payments. They're still taking payments all day long, every day. So that, because we kept having these problems in production. And we followed this simple rule. If customers see a failure, we're not going to let that happen again. We're willing to endure absolutely any humiliating problem, no matter how painful, exactly one time. But we have no patience whatsoever for seeing the same problem twice. And it's that basic rule that allows you to build up these systems incrementally, rather than trying to build them all at once, yeah?
So you don't, once I check in a piece of code, you don't have any QA until it goes to production?
That's right. We'll QA it in production sometimes if we think that's necessary. And the procedures have to be a little bit different for the downloadable client than for the web-based part of the product, so there are some nuances to that answer. But it is not necessarily QA. Let's go here.
But when you say you're queuing in production, that means that that feature may not be exposed to all users.
That's correct. Yeah, so quite often what we'll do is first we'll put a feature into production where only the QA team can see it, other people can't. Then maybe we'll take some early adopters and let them see it. Then maybe we'll do a split test that we're going to talk about in a moment to let a few percentage of randomly selected customers, and we'll kind of incrementally roll it out to more and more people. That gives us a lot of opportunities to catch problems that we wouldn't otherwise have caught. With the downloadable client, our biggest problem, since we're running 3D software on Windows, and God help you if you ever find yourself in this situation, it's a nightmare. Think about all the combinations and permutations of versions of Windows, drivers, 3D cards, and oh God, it's a nightmare. Our biggest problem is that we can't reproduce crashes in the lab. We have fixed every crash in the entire universe that can be reproduced locally. Yet our product crashes thousands of times every day in the wild, because there are just so many crazy, crazy configurations that you trip over inside. I mean, if you haven't actually done that for a living before, it's hard for me to communicate the pain of shipping 3D software on Windows. It really sucks. which means that in order for us to certify that a new version of the client is actually production worthy, we have to ship it to a percentage of customers and look at the crash rate. And so, I mean, I don't even have time to talk about this. One of the procedures that we operate is I think the world's most in-depth crash reporting about what's happening turns out Windows has about 95 different ways that a process can exit. And we have to catch and trap all of those to figure out what the hell went wrong. And then, we have a system that automatically compares the new software compared to the old software. Does it crash more often? What are the more common crashes? What do we do? And it will revert to a previous version if it notices the new version, just like with the immune system isn't up to snuff. Any more questions about continuous deployment? All right. I want to talk about what I call rapid split tests. And if you're getting a theme, when I say rapid, I mean extremely rapid. I'm talking about split tests that are so easy to write, there's literally no excuse for not writing them. Each test requires no more than one additional line of code to introduce. If it's more lines, my experience is people just won't do it. The system for measuring them, I don't want to talk too much about this, just whenever you're building a split test measurement system, make sure the metrics are actionable, accessible, and auditable, which means you remember the simple precept that metrics are people too. And behind every number in your system is a behavior that a human and everyone in your company has to be able to understand how the number relates to what people do. And the skeptics in your company need to be able to say, hey, it says 100 people did use feature X. Which 100 people? I'd like to talk to them and find out if they really use feature X. If your analytics system can't produce answers to those kinds of questions, you will not have the credibility necessary to do the next thing, which is what I call measure the macro. The idea here is that if you're doing a split test on a feature, even if it's the most minor feature in the universe, like changing the color of a button in order to increase its click-through rate, I beg you, do not measure the click-through rate. Why do you care about the click-through rate? You always care about it because you think it's going to impact customer behavior at some top-level way. Customers will spend more money. They will come back to the site more often. They'll be engaged with the product in some positive way. So measure that. See if the change has an impact at that level. And if you kind of don't think it's going to, don't make the change. This is one of the big differences between startups and companies that have to do linear optimization. The idea here is that if you're trying to tell the difference between the signal and the noise, you're already in the wrong part of town. Startups have to work in situations where the signal is overwhelmingly high. Like your product is either like horribly badly positioned, in which case minor changes don't matter, or like, boom, you finally found that first sliver of a radio signal, and now you need to really pay attention. It's not about figuring out how do we squeeze out the last 1/10% of our conversion rates. This is yeah, go ahead.
I just have two questions about this.
Yeah.
One, what's RPU?
Oh, revenue per user.
Okay. And the other is, so you seem to be organizing the users by the number of days they've been using the system?
Yeah. This just happens to be one of the reports, and these numbers are all fake, but kind of an example of a kind of report that we use. A version of this report combined with that one-line split testing system, which I think like the whole system, the reporting and the split test and everything was like 200-300 lines of code. I did it in like a couple of days. We use that system to drive our business, I think, for 18 months before we started to have to make it more complicated. So if you try to introduce this into your company and your engineers are like, oh, we need to spend a month on this, they have made it too complicated. Make it simpler. This is a very simple thing. It turns out that measure the macro has the advantage of being both extremely valuable from a decision-making and value point of view, and being basically the simplest thing that could possibly work. So there's a whole spec for this on my blog. If anyone's interested in discussing afterwards, I'd be happy to talk the intense details. But basically, we just want to say of the total number of people who are in version A or B, what percentage of them did these key activities for the business? And is there any difference between those two groups? Question back.
What's typically the lowest level of usage that you can get value out of a split test? Like, what's the critical mass? Or make things statistically relevant? That's
a good question. It's really how many customers are needed for statistical significance.
Yeah.
And unlike real science researchers, we don't have to answer that question, which is really nice. We get two.
You have to understand, my CEO just sees the latest user as 100% of usage.
Mine too. I live with that. The phenomenon of seeing the most recent user as indicative, which is actually not the world's worst heuristic, frustrating though it is. This is a little bit better. And the idea here is that you can just measure this test in real time. Like doctors, when they do double-blind analysis, it's really important that they don't see the data till the end. But we are under no such ethical restrictions. And our behavior doesn't affect the outcome in a way that doctors does. So what I would say is monitor these numbers until it's obvious that the signal is there or that you're in the noise. And my experience is, although there are some really detailed situations where you find yourself in a multivariate situation, or there are, I have run into those problems, but the overwhelming number of cases, like what the first 10 users did is what the next 1,000 users did is what the next 10,000 users did. So most of the time, the test is actually pretty obvious what's going on. So this is a judgment thing. There's no hard and fast rule, but that's basically what I recommend. Yeah.
Do you don't have an explosion of the combination of the running test? Because I test this version, this version, this version, this version, you have...
Yeah, it doesn't matter.
Okay.
People are equally likely to be in any permutation of tests that you can imagine. If you work out the math, you'll see that all the changes that might have cancel out, except in the very specific case where being in version A over here, and being in version D over here have some weird interaction effects. And although those tests are conceivable, and there is software you can buy that will help you notice that that's happening, and there's fancy math you can do to prevent it, my experience is in startups, that's such a minor effect compared to what we're looking for, it just doesn't matter. So I would say solve that problem when you see evidence that you're having it. Yeah.
How do you know that your changes from experimental PD are actually resilient? Because they're going to, there's not just buffering effect or something.
It's not what?
Like a buffering effect over the
And the question is, how do we know that the changes in a given hypothesis are going to be durable, that it's not just the novelty of the new change or something like that? We don't. And that's why I recommend more frequent, lower quality tests versus less frequent, more high fidelity tests. So if you just run these tests all the time, so anyone has an idea like, hey, we should change the name of that from X to Y, like 20 minutes later, boom, it's changed. Okay, look at the data 24 hours later, like, oh yeah, it doesn't make a difference, I pull it out. Like if it's casual, if you make a mistake on any given test, you'll very quickly notice, because you're doing these tests all over and over again. And the biggest benefit is that in people's heads, they start to build up patterns about what kind of tends to work and what kind tends to not work. And that's what's really powerful. Yeah?
How much overhead is your test development adding to your development cycle?
The split test?
Well, all over. I mean, you've got, tests that things that you're testing in production, things that you've got an infrastructure to maintain, you've got this thing, and then you've got...
So from the point of view of the engineering department, there is such a thing as overhead caused by these practices, but from the point of view of the business as a whole, it has negative overhead. That is, it actually accelerates our ability to do the one thing I think matters, which is achieve validated learning about customers.
Understood. But, I mean,
So,
if you have to sell it to someone, I mean, you gotta...
but like, if you have to sell them on the fact that this has a certain overhead, it means you didn't make the sale. This only works if the team has an actual conceptual agreement that we are in the fundamental startup feedback loop, and that's what matters. And if you can't make that sale, you will never get any of these practices to work, because from the point of view of any given department in the company, these practices are suboptimal. And the point I want to make to you guys is they really are suboptimal from anybody's local point of view. But they, in my opinion, are globally optimal. If you can't make that sale, can't do it. Last practice I just want to mention, this one is in some ways simpler than all the others, but it's more powerful than all the others combined. It's called 5 Whys. This is a core part of the Toyota production system. I'm not going to get into this in too much detail today. I just want to mention it because if you follow this one practice, you can rederive all the others. What it says is that anytime you see a failure, just ask why it happened until you get 5 levels deep in your analysis, and then make a proportional investment at each of those 5 levels to prevention for next time. So this is a generalization of that problem I mentioned of having every problem only once. I'll just give you one really brief example. Server went down. Why? Bad code. Okay, well, why didn't our cluster immune system prevent it? Oh, because it uses an obscure API that has a weird performance impact. Okay, well, why did the engineer do that? Oh, he's a new engineer. He didn't know better. Well, how come when he started we didn't train him properly? Oh, because his manager doesn't believe in training. Okay, we thought we had a technical problem of a down server, but actually we have a managerial problem. Someone who doesn't believe in training. So I would say make all 5 fixes. Bring the site back up, revert the code, prove the immune system, train that engineer, and get his manager interested in training. That's the true solution. All 5 acts are the true solution to any problem that you have. And the idea of the proportional investment is if it's a minor problem that affects only a few customers, don't spend a month on prevention. Just make a minor investment, but if it's a major problem, do a major investment. This will act in the grandest sense as that same speed regulator. The more problems you have, the more time you spend in prevention. The fewer problems you have, the less time you have to spend in prevention. And if you follow that process, instead of getting a perfect replica of a system that works well for my business, you will get to use your particular business as your teacher. The problems you have will teach you what you need to know in order to prevent them. That's the true understanding of the Japanese production system saying that every defect is a treasure. Every time something goes wrong, you have an opportunity to learn something really interesting about why that happened and prevent it from happening again. There's so much more I wish I could talk about. There's absolutely no way I can cram even this much into an hour. I think we're even probably already over time, but I just thought I would just kind of show this. You have a handout with some of these practices. Most are described on my blog. There's also going to be webcasts and workshops and many other venues where we can talk about this further, and please come to the blog, please email me, follow me on Twitter if you want to discuss. I'll also be around after the conference if people want to discuss. This is, to me, making this vision of how startups can be built a reality is what gets me up in the morning every day. So I really welcome the feedback. I really want to know how could I make the presentation, make these ideas better, stronger, easier for people to understand, and love to discuss anytime. So before I close, let me just say I fundamentally believe in the power of everybody in this room to make changes that we talked about today. That is, I think that some of these practices are so powerful that if you just start on the path with a tiny, tiny, tiny step, it will unlock the energy you need to take the next step. And so I just want to ask everyone, take one last moment before we close, and just indulge me for a second. Just think to yourself, one interesting idea that you had in the last hour. Maybe it's an idea that I recommended, which would be great, but maybe it's a better idea that you had because what I'm saying is crazy. That's fine too. But one thing you could do, literally in the next 24 hours, to make your company slightly better. And see if you could make a commitment to yourself, again, not to me, but to yourself, to implement that change. I'll just give you a moment. Thank you all very, very much for being here. Resources are on this slide, and I'm happy to take a few questions if there's time. Thank you.